programming, you realize a lot of the time the students mistake the class for an arena in which they come to solve. So they're mistaking the questions they get. Write a program to do this or write a code to do that. They're mistaking the program they are writing for the course. That is not the course. The course is us learning the language. If statements, how do we write it? Variables, how do we write it? Statements like that, how are they written? That is the course. That is the course. So then comes in the problem solving. What is the problem solving? You see, there is a reason why whenever you watch a movie, the IT person seems to be so knowledgeable. He's the one who is cracking the safe. He knows about this and he knows about that. It's because as an IT person, as a programmer, your knowledge base has to grow. One person once told me, as an IT person, you don't work for an IT firm. You work for a firm that does IT. Now, that wording there is a very important word. The company doesn't do IT. They use IT to solve problems, which means if you don't know how to solve problems, coding becomes difficult for you. There is a reason why whenever you see children speak, you would see they'll say TA, then they'll say ta, then they'll say PA, then they'll say pa, then they'll say LA, then they'll say la. Is the reason why they learn languages from that point of view. If you have children nowadays, they even don't do those things anywhere. Nowadays, they learn how to sound words because they have seen that if children can sound words, they can spell faster. You don't need to do ta, pa. You don't need to do that anymore. Why don't you do why don't you do that anymore? You don't do that anymore because you have evolved from thinking of the word to execution of the word. So when I tell you if something is palatable, you just say it is palatable, forgetting that there was a time in your life when you learned pa, ta, and now you are just joining them together to form words. My job as the teacher, the job as any teacher, is to teach you the syntaxes of the language. It's not my job to teach you problems. And I'm not saying that to be mean or to be a not nice or unrealistic. But if I could teach you how to solve all the problems of this world, guess what? There'll be no need for you. The reason why IT is so prominent and there are so many people in IT, and yet there are so many new apps coming and so many new projects coming is because people keep on finding problems in which they can use IT to solve in clever ways. So if you are the student who is learning IT and you mistaking the course for not the syntax, but you do not force yourself to learn the problem solving, it is you who's doing yourself a disservice. The teacher has done his job. He has told you this is how you write a for, this is how you write an if, this is how you write a function, this is how you use it. As to how you use it, how you implement it, it belongs to the student. So you realize you talk to students and then they'll say, oh, this teacher didn't try for us, or this teacher didn't do that. Did the teacher teach you the syntax? Because that was his job. And if he did that, then he's done his job. It is now up to you for you to implement those syntax to solve problems. Don't get me wrong, solving problems are hard. If they could be solved, there will not be problems. So to solve problems, you should be well versed with the underlying logic of algorithms as so to determine the best optimal solution in coding. That is why you get the small problems in which you solve in class. So you can see that your class rep asks a question when we're doing that. Where are the big things? Where are the big things that come in the coding? The big things come when you can do the small things well. For example, if you can boil an egg, then technically you can boil rice. And if you can boil a rice, then technically you can move on to other boiling foods that are more complex and difficult because you understand the nature of how those things are done. So get out of your comfort zone. Begin to brush up with basic data structures, begin to brush up with algorithms, begin to learn into in-depth the core of the concepts. It is recommended you take it slow and then you increase the difficulty as you are learning gradually and moving through. That's why if you realize the moment the question is easy, the next question is harder and it is harder and it is harder. And I don't give you the hard questions because I want you to be hard or the 5 marks that you would not get or the 10 marks is so important. It is not about the 10 marks or the 5 marks. It's about you being confident in yourself to know that I don't know how to solve this. I am finding a way to solve this. And when you find a way to solve this, guess what happens? When you want to solve another problem which is similar, it becomes easier. But my students always take the quickest route out. They will use ChatGPT. They would submit it to me. They will be happy in their rooms. Oh, we got 10. Yeah. Does the 10 really matter? If the next time you see the solution, if it's for a job or it's for an opportunity or it's for something very important, you can't execute. You should also ensure that you don't get comfortable with executing the codes with just one approach. That is why when you solve the question and you don't repeat the question, reducing the lines, reducing the number of statements you have, what are you doing? Because at the beginning of your programming journey, it is about us solving the problem. Then it is about who can solve the problem in the fastest, quickest way. Then it is about who can solve the problem in the fastest, quickest way that makes the logical sense. The idea is to familiarize yourself with different problem solving techniques and to build your coding skills. That is why I give you people questions to solve. That is why I give you time to solve. No evening student has ever messaged me and said, I am solving this question and here's where I'm stuck. So can you help me? None of you has ever done it. None. Which means you are either not solving or you're either not doing. And most of our classes are online, so I can't watch you and see if you are doing or not. And there is no trigger. And there is an assumption that getting some imaginary 10 marks or 5 marks or 15 marks from chat is more important. It is not. I can give each and every single one of you here 40 over 40 for your class score. But what is that if you would write an exam and get zero? Nobody is a genius. I was sitting with a class 2 days ago, and we had to solve some problems. And whilst they were solving and we were all suffering, I felt bad. Honestly, I felt like, are my students really suffering that much? So I also sat down and did it. And I did it within a very, very short time. The question I gave them, I hadn't solved it prior to me coming to class. So technically, we all solved the question together. I saw it online. I thought it would make sense. I gave it to them to solve. That was it. How did I solve it faster than my students? Because I learned very, very early through constant practice that no matter how big the problem is, if you can break it down into small segments and solve the small segments, you would realize that you have solved the big thing. When a question is given to students, the first thing that comes into their brain, even you people, the first thing that came into your brain when you saw the questions I gave you last week, the questions are plenty. Who cares? If the question is 1,000, 10,000, or 4,000, where is the challenge? Each one of you here, when you hear the amounts of money people take for doing IT, you are happy. But where is your challenge? Where is your, oh, okay, I'm going to do it? Where is that one? Your inability to identify a problem is your downfall in programming. Your inability to break a problem down into its barest parts is your downfall in programming. Because at the end of the day, your code is line by line. So all you have to do is just focus on the line. What do I have to do here? After I'm done with this, what do I have to do next? It's like you're constantly asking yourself questions. And each time you ask yourself a question, you look for a solution and you move on to the next line. And you'd realize that you would have built the entire program and you are done. So you can see on the slide, it says this will help you write simple, efficient codes devoid of unnecessary complexities. How do I break a problem down? I would create a flow chart. I would write it down in a small book. I would draw drawings. I would say, okay, you move here, you go here. Obviously, I have done that so much that I can do it in my head in a faster rate. That doesn't mean you shouldn't do it on the piece of paper. You realize that at a certain point in time, you would stop using the piece of paper and you can just imagine and see how each and everything should flow and behave and react. Arrange the functions in the order you need to do them. In case of an error, you can debug the code and search for an alternative approach. And it is here that we must talk about an error, whereby I don't know, but whenever you think of a programmer in a movie, you think that programming is like the things that happen in a movie. It is not. Contrary to popular belief, there is a lot of reading of documentation. You write some few lines, you get stuck, you go and read documentation, you come back, you write some lines, you go and read documentation, you come back. Programming is like you are constantly learning because they are constantly doing new things in which sometimes you don't even understand yourself, in which you have to find solutions for them and implement. So you must read. I always tell students, programming is not for the person who is always moving about, and it's for the person who can sit down for hours. Because that's sitting down for hours, you aren't coding for the hours. You would code tops, let's say, an hour. But for the hours, it is reading, finding routes, finding efficient ways of doing things. So we all get errors. If you don't get errors, then who are you? Every single programmer gets errors. Even the masters of the game get errors. There is no shame in getting an error. There is a shame when you do not know what the error is even about. It's like you go to the doctor and you can't tell the doctor what problem you have. You should be able to vocalize what problems you have. So I was watching something and it said the best programmer is the programmer who knows how to identify an error and knows what the error is. Because if he knows what the error is, he or she can solve. And there is no miracle to knowing how an error is. The only miracle is to try and error. That's why the more you practice, the better you become, because the more you see mistakes, and you don't go on those mistake loopholes anymore. As I said, in the beginning of coding, it's all about getting the thing correct. But at the end of the day, you realize that each individual is getting the thing correct. So the question moves from why are you getting the thing correct to who can do it the fastest. That means when you write your code, everything is correct, you're happy. The first 15 seconds, I did it. After that, you look for ways of reducing the lines you have. You look for ways of making the code smaller and shrinking the lines, because the more you shrink the lines, the more efficient your coding skills become. And that is what we are looking for. That is what we are aiming at. You must ask yourself questions in doing this. What is the best route do I take? Do I use this method or that method? Do I use this one or that one? Which one gives me more advantage? There are questions we ask. The slide here says we should learn from our past. How can you learn from a past that you don't have? You see, human beings by our nature, we learn from our past. If you take children, watching children is a fascinating thing. I don't know, because my life I've grown up with children around me all the time. I always watch them with fascination. You realize that the child will be there and the child will do something. And as he is doing it, for example, we have a store at our house, and the children always pass through the railings of the store and enter the store to take toffees, and then they will run out. But as they are growing, they forget that their bodies are also expanding, so they get stuck. So one of them went through and got stuck, and his head was inside. He couldn't get his head out, he was crying and screaming, and we suffered to get his head out. So the next time, when one of them wanted to do that, he held him and said, "Don't go." He wasn't telling the other one wanted to go because the toffees, he's small enough, he can pass through, but he was telling that person, "Don't go." Why? Because if you go, you get stuck, and he has experienced it. The same way, if you write code and you make an error and you suffer and you find why the error is there and you know why the error is there, guess what? If you have to write it again, there is something you don't do, and that is you don't do that error again. So my students who use chats and use all kind of means and let other people write your code for you and all of those things in which you do, guess what you don't do? You don't learn from your past because you don't have any past to learn from. I have been a student before. We all assume that coding is hard. Yeah, it's hard. I have been every single type of student you can think of. I have been a weekend student. I have been an evening student. I have been a day student. To be honest with you, the best kind of student I was a weekend student because I wasn't working and I had a lot of free time. But regardless of, I have been a student who knew nothing about programming and had to learn programming. And I've been a student who knew everything about programming and I still have to learn programming. I knew nothing when I started with C++, plus plus, and I knew so much when I had Python, and now I had to utilize the Python. And in each case, from one brother to another, from one friend to the other, from a student to a pupil, practice, 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 practice. That word is not a word you throw away. You practice, you make mistakes, you find out why the mistake is there, you practice, you cut your code down, you practice, you practice, you practice. There is nothing like there is no time. Because right now, if I told each of you that I would give you $1 million if you could find 2 hours a day to run from for an hour and come back home, but you just run for an hour, come back home, and I would give you $1 million. Trust me, you would find time to run for that hour a day because that money is what you need. But when it comes to your education, when it comes to your improvement, when it comes to a skill set that has proven to see that people have become rich in, and when it comes to a skill set you can learn from, guess what my students don't do? Practice, practice, practice. Because there is always an excuse. There is work and school is difficult and I don't have time and I have to do this. But you see, at the end of these 4 years, there is a stopping point where you have to now implement. When are you going to implement? When? And as I said, there is no evening student, apart from your class rep, who did in the beginning, but there is no evening student who has ever said, Sir, I wrote this code. Is it correct? Is it wrong? Is this? Is it that? None. Like I said in the beginning, my job is to teach you the structure of the code. I have done that. You realize that when I'm teaching you, I always say, if you don't spell something right, or if you don't do this right, then I will deduct some marks. I never talk about your implementation of your code because that is subjective. So if I think you are implementing something well, you get the full mark or half the mark or something based on what you are doing. But for the structure, it's like when you listen to someone and said, he did go come or I came, saw, or, like the English grammar is wrong. That is how the coding is. When the structure is wrong, when there is no indentation, when you yet haven't figured out yet, your exam would be on paper. So you must practice on paper. Instead of complain, complain, complain. Are there any questions?
No, sir. No, sir.
Let's talk about Raspberry Pi. A Raspberry Pi is a small, low cost credit card sized computer developed by the Raspberry Pi Foundation. It was originally designed to help people learn computer science and programming, but its affordability, versatility, and community support has made it popular far beyond the classroom. Here are some key points about Raspberry Pi. Number one, the hardware basics. It has a system on chip. It is typically used in an ARM-based processor, which makes it energy efficient and able to run a variety of operating systems. It has storage, which comes with an onboard RAM, which also uses an SD card as its main storage medium. There are ports that you can use to connect the USB, your HDMI, or your GPIOs for connecting interfaces and other Bluetooth devices. What operating system does the Raspberry Pi use? It uses the Raspberry Pi OS, formerly the Raspbian, a Debian based Linux distributed optimized for the Pi. Other operating systems include Ubuntu and then specialized Linux systems. Even you can run a lightweight Windows 10 for Internet of Things core. So Raspberry Pi, you can install on it various operating systems to do what you need to do and to manage what you need to manage. Now, what's the difference between Arduino and Raspberry Pi? Last year you learned Arduino. Now you are learning Raspberry Pi. Why are we learning Raspberry? Arduino is a microcontroller-based board, and it's essentially a programmable circuit board that runs simple code you upload on it. So if I have an Arduino, I upload some code onto the circuit board. That code remains on the circuit board and then runs that whole circuit. For the Raspberry Pi, it is a computer on its own. It has a single mother board or a single mother computer, and it is capable of running a full operating system. We can save things on it. We can put programs on it. We can put 3 or 4 programs on it. We can remove them. It is a computer pledged on its own. Even though it is small, it is a whole computer. Arduino is not a computer because it doesn't have a process. It doesn't have the a board on it. It just has a microcontroller board in which you can just run one program at a time or 2 programs at a time or whatever code you put on it to execute. Arduino, no operating system. Programs are written in C++, compiled directly onto the microcontroller. You have to direct low-level access to the pins for you to utilize that. The Raspberry Pi, it runs a variety of operating systems, and you can install and run multiple programs and manage files and even run a desktop environment on it. The processing power. Obviously, the Arduino's processing power is limited, and the Raspberry Pi is far more advanced because it needs it to power its operating system, motherboard, and memory, and other peripherals in which it's connected to. When do I use Arduino? I would use Arduino if I'm building some motors or I want some LED lights or I want to build a simple embedded system where the responsiveness is low. If I want to build a system that has computational power needed at site, it has networking capabilities, I want to do advanced programming, I want to do frameworks, I want to run a server, I want to run a media center, I can run all of these things on the Raspberry Pi. Raspberry Pi uses C++, but Arduino uses C++, but the Raspberry Pi can use either C++, C, Java, or Node.js. For example, if I want to run an application like I'm at work, I'm coming home. When I'm coming home, I want all the air conditioning on, I want the boiler on, so that by the time I get home, the room is cold, the boiler has already boiled, I can shower and then have a nice home environment. I would use the Raspberry Pi, I would use Node.js, and I'll connect it over the internet so that when I click a button, it will be transferred to my house and it will apply. Let us write some code on the Raspberry Pi. You guys are already familiar with the walkway. So here I have my walkway. Are we familiar with it already? You use that when you're doing the C++, right?
Yes, sir. Yes, sir.
So in there, I'm going to click on MicroPython. But before I click on the MicroPython, I have to click on, 1 second, this Pi Pico. Are we okay? So I'm going to click on this, the Pi Pico. And when I click on the Pi Pico, I'll go and look for the MicroPython. So this is what I want to use. I want to use MicroPython. So I'm here now. Over here, we have the area we can write our code. If I want to add a new file or upload a file or rename a particular thing or delete something, I can do that over here. Over here, I have my diagrams JSON file, which keeps all my designs, my parts, the connections I make, and the dependencies that are used to help it do what it needs to do. All of them are controlled from this section. We're going to build a simple application. I need items for my application, so I'll come to the simulation side. I have my run button here. I have my add button here that I can use to add any parts in which I want. And then I have my buttons here that I can use to either make it a full screen or fit the screen or do whatever I need to do. For your purposes, I'm going to make it a full screen. And then in here, I'm going to click on this button here and go for an LED. So here I have an LED. And then I'm going to click on this button here again and go for a resistor. So now I have a resistor over here. So I have an LED and I have a resistor. I have been informed that you people have done electronics. So what is a resistor? Who can tell me? Mr. Owusu, what is a resistor? Mr. Owusu, are you there?
Yes, sir. So,
I can hear you.
resistor is a passive component that opposes the flow of current in a circuit.
Okay. So in this scenario here, why am I introducing a resistor over here? The resistor is going to help me to oppose the current coming into the LED to make sure that the current that comes here is appropriate and correct so that it doesn't blow it or spoil it or do anything like that. So with that in mind, I'll click here. I can see that my resistor here is 1,000 ohms, in which I think it's a bit too much. So I'm going to reduce the ohms to 330. I'm going to reduce the ohms to 330. How do I reduce the ohms to 330? How do I do that? So I will click here. I can just change the value over here quite easily by just changing the information I have over here to 330 and then change this one to ohms. So I know that now I'm dealing with what? 330. I can also come to the the JSON file here and change it directly where I have the value section in the attribute section to 330. Also, I can change the color of this. I can make it blue or yellow or whatever, but for now, I want to maintain it as what? Red. Now, in over here, making this thing bigger again, I need to connect this. So I'm going to connect it from here. I'm going to choose this side, come here. If I want to break it down, I just click on the screen. So I'm clicking on the screen here, and I'm taking this until I find the ground. So I'm at ground 8. And I'm going to connect it to this. So I'm going to click here. I'm going to click the side here, come here a bit, come down here, and then directly here. I'm going to connect this one to number 15. So output number 15, which is over here, is what I've connected to. So I've just created a connection for my entire circuit over here. I'm going to leave full screen mode. I'm going to leave the JSON. And in my main, I'm going to write the code in Python that will make this light come on and blink. So I would come in here, I would wipe everything off here, and I'll say from machine import pin. Now, the pin over here allows us to have access to all the pins we see here. So you can see Pico G1, G ground 1, G2, G3, G4, all the way up to G15. And over here, we have also other pins here that can be utilized. So this enables all the pins to me. I also want to import time. Now, time will allow us to control the events of the things which happen on our screen. I'm going to create a variable. And we all know what a variable is, so I'm creating a variable called let. And I'm going to make it equal to pin into bracket 15. So you can see that over here, I'm picking information from pin 15. And at pin 15, I want the information that I am picking should be pin dot out. So I'm picking information out of the machine. Now here I'm going to say while all actions remain true, I want you to do some things for me. I want you to take the pin I have just, the LED in which I have just created, in which is taking information from pin 15, and I want you to toggle it. That is, I want you to send power through it. Now, I want you to invoke time and let it sleep every single second. I'll save my work as evening. So now, when I run this button here, power will pass through it, it will sleep, then power will pass through it, it will sleep, then power will pass through it, it will sleep, then power will pass through it to sleep. And if that happens, you realize that my LED will just be blinking light every single what? Second. Are there any questions, please?
So can I ask a question?
Of course.
So I wanted to know if the connection should be only between the ground and then the pin 15.
The connection to the ground is very important because it is electricity passing through. So you are passing it from here all the way here, it gets to the ground, and then it flows back. You understand? So if it doesn't go to the ground, we have a very big problem
Okay, sir.
because it's electricity. So the ground
Yes, sir.
connection is a very big problem. And then technically we are taking power from here. But when the power gets
Okay.
here and then it gets here, then it goes to ground. So it is dissipated. You understand?
Yes, sir. Yes, sir.
So it is
Thank you.
not a circuiting which we are passing power through. So we are taking power from here. That's why we are saying that this is pin out. So all power comes in here. When it gets here,
Okay.
electricity passes through this light comes. Then we will say put off the light. Then the electricity is constantly passing through here. Then over here, we are saying that when it gets to the ground, it should be dissipated. Are there any more questions?
Yes, sir. So hello?
But the way you asking me questions is the same thing you did in the Android, the Arduino, or okay, what's it? I'm listening.
Yes. So I wanted to find out, like, how would you know that you are supposed to pick power from uh, the Pico 15
How
along
would you
all the
know?
pins? Along all the pins, why did you pick from the GP15 and then why not GP3 or GP5
So
or
I
something?
could pick from 14. That means that here I'll change it to what? 14. And I'll run. Do you see that? So the
Okay.
pins here,
Mm.
you can pick from anyone. And
So
before you come and ask, uh, that is why it is a simulation. And you can do try and error. Ah, okay.
okay, so it
Uh-huh.
means that the pin you pick from, you need to state that in the code.
Of course, you are telling the computer that the LED is picking the information from somewhere. So where is it picking it from?
Okay.
Any more questions? Let's try another one.
Sir,
Yeah,
so I wanted to ask, but you didn't label the resistor in the code.
I didn't label the resistor in the code.
Yes, I don't see that in the code.
Over here.
Yes, please.
Why will I label the resistor? Well, I'm not like, I want to understand your thinking as to why you think it should be labeled or you think it shouldn't be labeled. I want to know why you think so.
So I'm asking because the lead has been labeled in there, and I was thinking the resistor should also be labeled. That was why I asked.
Okay. So we asked Mr. Owusu is it Mr. Owusu? Let me see if I got the name. Mr. Owusu to explain to us what a resistor is. Mr. Owusu, what did you say? Mr. Owusu, are you there?
Resistor regulates power that's passing through.
It regulates power passing through. That means we don't need to refer to it because it's doing its job. It means that when power gets here, it is reduced. It would impede it. So if 100 is coming, it will reduce the 100 so that the one you would get would be convenient for you. So it is doing its job. It is this one that we want power to pass through. And when power passes through it, we want it to go on and off so that it would blink light. So there is no need for us to do anything with the resistor because its job is to impede the power that is passing through. Manasseh, do you understand?
Perfectly well said.
You have done the electronics, so all you didn't do.
So we did it. It's just a
What's the number
question.
of
I
what
just
is the
wanted
number
to
of the
ask.
electronics teacher? Let me call him right now because there are conversations I have to have with him. Because the students are saying one true. No course, no one true. Let's see if we can do another one. Okay. So I'm going to start a new walkway project. Then in here, I'm going to pick up LEDs. So I'm going to pick one LED, two LED, three LED. So over here, I have one LED here, I have two LED here, and I have my third LED. Now, this thing here, I'm going to rotate it. So I'm going to tell the computer that it should rotate by 90 degrees. The walkway Pi Pico. So you can see that it has rotated it by 90 degrees. So we can write code in the JSON file. The JSON file has the editors, the author's name, and so on and so forth. A very key important note that in your exam, it means that this place will have to have your index number or those kind of information. And then over here, we can see that this function here, whenever you start the program, will be given to you. So that is for this. And then all of the things which come under here are your LEDs, and we have LED1, LED2, LED3. So now here I can change the color. For example, I can change the color directly from here to make it blue. I can change the color here to make it, let's say, green. Green. I can change the colors there directly. I can also go in and click on it and then come and click here and then change the color from here. I can make this thing orange, or I can make it blue. I can make it any color which I deem fit to advance the programming which I. So in here, I'm going to put this one here. I'm going to put the second one over here. And I'm going to put this third one over here. I'm going to move the project a bit here. I'm going to make it a bit bigger. And then we have this. I'm moving it. So now I'm going to go on full screen. And then in here, I'm going to do some connections. I'm going to do some connections. I'm going to say this one here should be connected to port 6. I'm going to say this one here should be connected to port 7. I'm going to say this one here should be connected to port 8 or pin 8. I'm going to say that after connecting them all together, I want to now connect them in series. So I'm going to connect this angle here. Remember, when you click the screen, then you form a location. So I'm connecting it down here. When I get here, then I come here. So I've done my first connection. I want to connect this one. I'll come here, I'll go here, here, I'll come here, here. And then I'm going to connect this one to the ground. You can note that we have the ground over here. Ground 4 is here. I think ground 3 is somewhere here. So I'm going to choose to ground it to ground 3. I could have grounded at ground 4. Before class rep would asked me, say, can I use ground 4? You can use ground 4. So now I've connected these devices together. Now I want these lights to blink. So I'm leaving the full screen mode. Cancel. And then I'm going to my coding area. And I'm writing the code for this. And in writing the code for this, I'm going to say, just like I said for here, that from machine, I want pin. I also want to import time. I want LED1 to be equal to pin 6, pin dot what? Out. I want LED2 to be equal to pin 7 LED out. I want LED3 to be equal to pin 8 dot LED out. While everything is true, I want LED 1 dot the value of it to be 1. So here I've just turned it what? On. I'm going to do the same thing to LED2 and LED3. Now I'm going to tell the computer that time dot sleep is zero point 0.1, 0.5, half a second. And I'm going to say LED, the value should be, I can just copy all of this, put it here. Perfect. Here I'll make it 0. Here I'll make it 0. And here I'll make it 0. And then here I'll make it what? 1. And then I will start my program. And the lights are supposed to come on, and they didn't come on. So I have an error. It says that type pin has no attribute out. Okay, so I stop it. And it is true. Pin, the out is all capital letters. So that's my error. Again, so that when I got an error, I trace back to what I didn't do right. What didn't I type right? I didn't run and say I'm stopping coding, because coding is hard. Let me call it evening 2. So now when I run the program again, LED2 isn't defined. Let's see. Where haven't I defined LED? Error in the name. LED2 isn't defined. Okay, let's stop it. Let's go and see why LED2 is not defined. So here we have high voltage, low voltage, low voltage. That's okay, no problem. Let's stop. So we have LED1, which is Geo9. 2 is Geo7. And they are saying Geo7. And they are saying pin 7 doesn't exist. Is that true? Yes, 7. Let's go to the JSON file. We have 7 over here, and we can see that LED2 is connected to Pico 7, and the color of it is green. But here I can say the color of it should be blue. I see the difference. So yeah, there should be nothing wrong with that. Let's see what I've done wrong. Yes, making sure everything is correct. LED1, LED2, LED2 isn't defined. Oh yes, LED1 2 is not defined because here I made the L capital. It's not small. So now I've made it back into. Let's run it again. Now we can see that our lights are what? Blazing. We have one light here, one light here, one light here. All of them are going off at the same time and harmonizing. Are there any questions, please? You can see that here I didn't use any resistor. And that is not a good practice because remember, the Raspberry Pi devices, to us, they are a bit expensive. I know in the thing I said they are very cheap, but in our side of the world, they are a bit expensive. Let's put it that way. So if you don't put resistors in your circuits and the power becomes too much, it can blow your LEDs, or it can even blow your device itself. So introducing resistors into your system would help to stabilize the current that goes especially into the LEDs. Very, very important. But you can leave them out. This is a simulation, not going to blow anything up. So you can leave them out. But again, if it is what the real world, you would want to put the resistors in to moderate the power that is coming into your application. Are there any questions?
No,
If there are no questions, then I'll leave you here. There are 2 videos coming you. Each of them have different applications that were built using the Raspberry Pi Pico. And they have different difficulty levels, different connections, different ways of writing the Python code to talk to it. So you would have 2 different versions to try out before the exam time is up. Is that clear?
yes, sir.
We will meet again and talk about the exam before you write the exam. Note that the exam will be on the 13th. That's when you're starting your exam next month. So we'll break on the 20th, come back on the 13th. But I'll talk to your class rep so that we'll meet somewhere within that time so that we can have a proper chat about the exam. But when I send you the video, please
Yes,
watch.
sir.
Please
Yes,
practice
sir.
the video. Practice the video. Practice the video. Then and let me know how it goes with whatever design thing you're able to build from the video. If there are no questions, I'll bid you a farewell. And I'll make the class video available to you in the next 10 minutes.
Yes, sir.
Bye bye.